Okay, so the plan for today is just to do 3 to 4 problems because when we did the last class when we discussed proofs of some theorems and what modernity is, a lot of the ideas are covered there. So even in today's problems, you will see that we'll be just developing on those ideas. So if I just give a solution to all the problems, that won't be helpful. And this is why this class is like shorter and just 1 hour long because I want to give other problems for you to practice. But we'll still do some problems so that you know how to think about those. And before we start, I'll ask just one more time if anyone has any questions regarding modular arithmetic. So yeah, if not, then we can just begin. Okay, so we first do an easier problem. I forgot to latex the problems because I was traveling. So I'll just type them out. Right then. Evaluate 2 to the power 3, 0 plus 2 to the power 1 by 3 plus 2 square by 3 plus so on till 2 to the power 1000 over 3. You have to find this sum. For those of you who don't know what this means, this is GIF function, greatest integer function. I hope this is clear to all of you what this means. If not, you can ask me and then I will explain. Take 2 3 minutes and try this problem. If at any point my voice is too low, please let me know. Okay, I hope it's not low because I'm loud. Okay. Uh, is it now better, the voice? Is it audible, Ashutosh?
Yes, it's
Okay,
audible.
okay, thank you. Okay, so the hint is, see, you need to compute for, in general, you have to compute this thing, right? 2 to the power I by 3. So let's first try for base cases. For I equals to 0, this is 2 to the power 0 by 3, which is 1 over 3, and this is just 0. For I equals to 1, this is 2 by 3, which is again 0. For I equals to 2, this thing is 2 square by 3, which is 3 plus 1 over 3, and which is 1. For I equals to 3, this would be 2 cube 8, 6 plus 2 over 3, 2. Okay, see, so here we see that here the remainder is 1, here it's 2, here it's 1, here it's 2. So like there is some pattern following, right? So if we just, in general, if I have to find A by B, this thing, right? Let's say I can write A as N Q plus R. Sorry. BQ plus R, where R is in this range. Then can someone tell me what the value of A by B will be equals to?
Q.
Yes. So when I divide this thing by B, A by B, this thing will be Q plus R by B. Now this is an integer, and since R is less than B, this thing is less than 1. So it's just this thing is some number between Q and Q plus 1. So GIF will be Q, right? So now I can write this thing as if A is BQ, I can write this as A minus R by B, right? This thing will be Q as well, right? If A equals to BQ plus R. Is this clear? Like how this thing came?
Yes.
I don't remember the answer, Gulshan. That's not the point though. Okay. So yes. So basically, and this R is like the remainder when you divide A by B. So what is R? R is my A modulo B, essentially. Right? So now this makes our life much easier. So now I have to find 2 to the power I by 3. I can write this as 2 to the power I minus 2 to the power I modulo 3 over 3. Right? Uh, okay, now what is 2 to the power I mod 3? How do I find this? Once I find this, I can calculate the sum, right?
2 to the I is just 1 mod 3 when I is even and else it's 2.
Yes. So you can try this. Okay, for those of you who don't know why this is true, try some base cases. And as a proof, you can induct. There exist simpler solutions as well. I'll just give quickly. See, let's start with 1. This is 2. Then 2 into 2 is 4, which is 1. So it's just now a cycle. So this is for odd stuff and this is for even stuff. But this is slightly like might be hard for people who have not seen this idea before. So you can induct as well. With time, you'll get to use to this idea. Okay. So this is 2 for odd I and 1 for even I. The remaining problem is just an algebraic sum. So like you have to find summation 2 to the power I by 3 for I equals to 1 to 1000. What I can do is I can separate the odd terms. I equals to 1, 3, let's say I equals to odd and I less than equals to 1000. And then I can find this thing here for odd plus I equals to even, I less than equals to 1000. This is the same sum. And now for odd, I can write what is the remainder when it's odd? 2, right? 2 to the power I minus 2 by 3. And this will be 2 to the power I minus 1 by 3. Okay. I'll leave this as an exercise to you. It's an algebra problem, nothing number theoretic in this. You can find clever ways to do it. Not useful in this class. Okay. Let's move on to next problem. Okay. Okay, a side question before we move on to the next question. Um, this is not related to number theory a lot, but it will be used in the next question. So I just give it to you as a hint before the question. Prove that there are infinite primes. There is one very basic proof of this thing. The someone know.
Yes,
Yes,
it
I
is
know.
Euclid's proof. It is
Uh,
Euclid's
I
proof,
don't know that. I don't know the name. Can you just give the idea?
where we take all prime numbers till the last prime, and we then multiply all of them and then add one.
Yes, amazing. So suppose there are finite primes. Okay, since they are finite, I can like number them, right? Let's say there are P1, P2, so on till Pk. Now I consider this number P1, P2, so on till Pk plus 1. Like if this number, according to my claim, see, this is clearly bigger than any of the number in this set, right? So it can't be in this set. And according to my claim, since only these are the possible primes, this should be composite, which means some Pi must divide this thing. If people are not familiar with this notation, like sigma A just means like A plus B plus C, so on. Pi of A just means A, B, C, product, just instead of sum. So this is product of primes plus 1, same thing here. But is this possible? Like this is saying product of Pi plus 1 is congruent to 0 mod Pi. No, right? Because this thing is 0 mod Pi. So this is equivalent to 1 mod Pi. So we are saying 1 is congruent to 0 mod Pi, which is not possible because we know the minimum prime is 2 and 1 equals to 0 is only when this thing should be 1. So it's a contradiction. So there are infinite primes. Okay. Um, the idea, the thing was, I don't want to discuss too many proofs of this thing. I just wanted to tell you this proof because it will be used somewhere in the next proof. I mean, like you don't have to think along these lines as well only. One second, let me just quickly ask. So this is the problem. So what the question is saying is, you have A and B as relatively prime. So GCD of A comma B is 1. And you have the arithmetic sequence A comma A plus B comma A plus 2B, so on. Right? Infinite arithmetic sequence. You have to prove that there are infinitely many pairwise relatively prime terms. So basically, I want to prove that there exists, this is just another way of saying the thing, infinite P comma Q such that A plus PB comma A plus QB are co-prime. This is just another way of stating the problem. Yes, annexed that's also like almost a similar proof. It's just you can say that R is slightly stronger than the proof that you gave, but doesn't matter for this thing.
We can fix one of P or Q, right?
I mean, you just have to prove there exists infinite such pair. So
Okay.
you can, if you want to fix, you can. If you don't want to fix, you do not want. You do not need to. Up to you. Okay. No one will use Dirichlet's theorem in this problem for whoever knows the theorem. I'll tell you after the problem. It just kills this problem. What Dirichlet's theorem is. But to answer your question, the version no. I mean, that's a valid proof, but let's stick to more elementary things. If you can prove me Dirichlet, I'll take your proof. Sorry, I can't understand you, whoever was speaking. I don't see why that is true, Aditya. Like, I see why GCD LB comma A has infinite solutions, but how do you work with this term? Like, you need this to like, let's say I just say this LB comma A plus PB. Like, how do you go from here to LB comma A?
I think putting P equal to
Oh,
0
that was
and
not
Q as the
O.
prime, right?
Yes, yes. Okay, this
Yeah.
is a nice solution. Yeah, yeah, yeah. Okay, so I'll just tell Aditya solution. Very clever. So what you do is you take P equals to 0. Uh, then you want infinite solutions to this thing. And this is same as GCD of A comma QB. Since GCD of A and B is 1, just take a prime, like take Q as prime, let's just say bigger than A, because then it will definitely be co-prime than A, right? So this means GCD of Q comma A is 1. And since you know GCD of P comma A is 1, you are done with the problem. Okay, nice. Cool. Let me think if I can generalize this problem to something more. Just a second, let me. Okay, suppose you have to like not fix P and Q. Like you cannot fix one of those. You can still do the problem. I tell you that. So, yeah.
Wow.
Uh,
That can be just take consecutive terms.
as in, what do you mean by consecutive?
Like if I take a plus nb and a plus n plus 1b, so their ratio, like their GCD will be the same as a plus nb and b, which is the same as a and b. That is they are co-prime.
This is work. Then this is a bad problem. Right. I did not realize this before putting the problem. This just works. Be right and consider arithmetic products together in 20. Mm, okay, I rephrase this problem in a completely different way, which should be fine. Let me think 1 second. Because that does not involve any modular arithmetic. And I just want to like tell you some nice thing with the solution. Uh, let me, this is right. Okay. So, okay, this is my this. I give you a like, let's say a harder version. Prove that you can find a set of arbitrarily large size terms from the arithmetic probability, which is just stated above. I'll just write it A plus BN, such that all the terms are pairwise coprime. Okay, now the issue with this is like the right, then you can just no, you can probably. Okay, hopefully this is not that simple. No, I mean I don't care about countable, uncountable. Is the problem clear, by the way? So I can, like, my problem is saying, I can find a set of size even, let's say, 1 million, and it has all the set has like all the elements as the terms of the arithmetic progression, and any two terms are co-prime. Let me just quickly confirm if the problem is true. I think it is most likely true. So I'm
Yes,
not scamming you.
think I have.
Oh, oh,
I think
huh?
I have some. I think I have a solution.
Okay, go on.
Yes. So what we do is that we first start with the terms a plus b and a plus 2b. These two are clearly co-prime.
Yes, a plus b
Then
and a
what
plus
we
2b.
do is that we multiply these two and then multiply the product with b. So we get b multiplied by a plus b multiplied by 2a plus b, and then to the whole thing we add a. So
Okay.
like we add a. So this term is also one of the terms. This thing is also one of the terms of the AP, and it is co-prime to the
Yes.
above, like the above terms. So it should satisfy, and then we can just
Uh,
create it.
okay. That might not be always true. Let me tell you why quickly. Just
Like
a second.
because all the terms here are co-prime with a as well. A plus b and a plus
Okay.
2b will be co-prime.
No. Okay. I'll give a counter example. Take a equals to 2. Then then 2 divides a plus 2b.
Uh, 2
Like
divides
my
a
b
plus.
is 3.
Oh,
So ab are
oh,
co-prime,
okay, okay.
right? 2 divides a plus 2b, right?
Yes,
Yeah. But 2
but
divides this
like
thing also, because this is even and this is.
yes, okay.
Can
I
you
think
just
this is
Yes.
guys
very close
sorry.
though. There's okay, go on.
No, I was asking, can you just explain the problem once again?
Oh, you want me to explain the problem once again?
Yeah.
Okay. See, so we have this AP, right? A plus B, A plus 2B, A plus 3B, so on, right? So what I'm telling you is, show me that I can find a set with size, let's say 1 million. This can be a billion as well, like as large as I want, the size of the set. This is my set S, and it consists of the terms in the AP. So that any two terms, any two terms in S are co-prime. Okay, I'm not 100% sure if there exists a solution. I think it does, but since I have not done this problem before, it's possible that I might have fixed all. So we'll see when I present the solution.
What about like
Hopefully it does.
a comma a plus p1b, then a plus
A, then
first term is a,
uh, some, okay, first term is A. You can take it. Yes.
then a plus a into b into a plus p1b.
A into A plus P1B into
B.
plus A. You are saying this term?
Yeah.
Right. This might work. Let me think. No, again the same issue. No, what if A is equals to 2? This is even, this is even.
P1 is greater than a.
What do you mean?
P1 is a prime greater than a.
No, I'm saying like your initial set is A comma A plus P1B, right? This is your
Yeah.
initial set. I am saying take A equals to 2. Then this is even, right?
Okay.
But your this term is also even.
Yeah.
Sum of two
Okay.
even numbers.
You can just take a comma now.
A comma.
A
Okay.
common in this third term.
Sorry, I didn't understand. Can you repeat?
You can take a common from the last term.
Right. So what do I do
And
with
it's
this?
just does not make sense. Like it's not co-prime.
Right. Okay, you meant that. Yeah, fine. Yeah, okay. I'll give you an idea. So let's say we have a set. Okay, we have to basically construct a infinitely large would be wrong to say because you cannot construct infinitely large. Okay, let's say we have a set of size m, a plus k1b, a plus k2b, so on till a plus kmb, right? This set is of m size. I want to construct as large as a set I want, right? So what I ideally want, like what is my one baby step? If I can construct, if I can find a set of size m plus 1, right? This is what I want. Like if I've set m size set, if I can find another m plus 1 size set, then I can just keep doing it and find any large number of element set, right?
So you are
So
suggesting induction.
yes, basically, I'm suggesting induction. So now what will be the most easiest way to do this? Just to add one element in this set. So like if I can find a plus xb, which is co-prime to all of these things, I will be done, right? So try to find that.
We can multiply them and add one.
Yeah, basically we can just multiply all the KIs and add one, just like the previous
But
one.
that does not
That
ensure
might
that it
not,
will be the AP.
yes. Because let's say even if we have a plus 2b and a plus 3b, I multiply this, it will be like a square plus 5ab plus 6b square,
No,
right?
no, I
Like
am not
sure,
saying about that. I am just talking about the multiplication of all KIs and plus one with that multiplication. Like if we have a plus 2b and a plus 3b, so we will generally
yes,
take that a plus 7b.
right. Does this always work? Let me think. Right. This does seem to work. Yeah, this should work. Yes, this should work. Okay. So wait, should this work? Just a second. Just please. No. This might not work.
I
Yes.
think I have
Okay.
a solution.
So let me just tell that why that does not work. Then you can give the solution. Is that okay? No, it does work. I'm confused myself. Let me calculate. Yes, that works. That works. I'll tell that solution and then I'll listen to your solution. Okay. So what he said is you have this thing, right? So consider this element, right? Let's now find this GCD with A plus K1B. Like we can take any K, but let's just take K1 for now. This will be equals to, yeah, it doesn't work. Sorry, it doesn't work. You can see that from the base case itself. Uh, A plus 2B and A plus 3B you had, then you construct A plus 7B. Like, how can you guarantee that these two are co-prime? This is like 5B and A plus 2B. Okay, in this case they are. No, they are not. Yeah. I'm just clowning a lot today for some reason. I can find a quick example for you. Let's say A equals to 3 and B you can take as let's take this as
One.
2.
One.
Okay, yes, fine, that works. Anyway, the person who said who has a solution, go on.
Yes, sir. I have the solution that we start with a plus b,
Hmm?
then a plus 2b,
Okay.
Then we continue with a plus a plus b into a plus 2b into b.
That might not. Okay.
Mm. The first 2b will not be. Oh yes, yes, yes. Plus a.
Okay.
And from here on, we continue this thing, multiplying the previous terms, all the previous terms, and adding a. Yes, and multiplying the previous terms, we also multiply with b.
Right. But what's the guarantee that this is co-prime? I don't see a direct way that why this should be co-prime. Right.
I have an I have an idea.
Okay.
First, we can take a case such that it is mod. It is 0 mod b minus 1.
Oh, you're saying take a case as that 0 mod b minus. Okay.
And then multiply with any arbitrary, and then multiply it with all other case, and then add 1.
So you're saying this term, right?
Yes.
Why did you do this? So you're basically just saying that I do like b minus 1 times t. Oh, sorry, not here. Like I just do something like this,
And yeah, it should be
right?
like k should be equal to. No, I don't think it will work. Will it work?
Yeah, this won't work. Okay, no, it won't. It's the same reason as someone just said this thing. Okay, I'll give you an idea, and this idea is used like a lot often. Okay, like in number theory questions, so it's kind of important. So you had this set, right? A plus k1b, a plus k2b, so on till a plus kmb. If I have to add some term a plus km plus 1b, which is coprime to this thing, right? So what does coprime mean basically? Like it's prime factorization, whatever with the prime factorization, like those primes will not divide anything in this thing, right? Does that make sense? So what I
Yeah.
can do is, let's just consider this set P. Let's say this set S, P of S, I'll consider as the set P1, P2, so until let's say Pt something is the set of all primes which divide some term, some element of S. Is the definition of PS clear? Like, let's say I have a set with 3 elements, A plus B, A plus 2B, and A plus pi B. Maybe they're coprime, maybe they're not. Let's assume they are right now. This is by 2, 3. This is by 5, 7. And this is by 10, 11. So my set P of S is just 2, 3, 5, 7, 10, 11. Okay. So this is the definition of P of S. What I now do is, if let's say A plus XB is P1, P2, so on till Pt plus 1, then my problem would be done, right? Because none of the Pi divide this thing. But what is the issue here? Like, it's possible that this thing is not in the AP. That's the issue, right?
Yeah.
But let's say I take another factor here as t, and t can be any integer, any natural number for that matter. Maybe this belongs to AP, maybe it doesn't. But what is this thing equivalent to? A plus xb congruent to 1 mod p1, p2, so on till pt. If I can find such an x which satisfies this equation, then I am done, right? Is that clear? That why I am done?
Yeah.
Yeah.
Uh,
So if we
that
move,
like 1 second, Aditya, that is not guaranteed that it will work or not. Like, give me a proof, then I'll say that it can work or not. I'll have to take time to think about that. And we are slightly short on time. Yes, someone was saying something.
yeah, so if we move one to the left hand side, we can't make that sure now that it will be zero mod all these.
Okay, no. I'll tell you that a solution exists to this thing. Maybe I just give you this as an exercise. Okay. I have done this in my modular arithmetic class. I have proved that this has a solution. I have proved this in my previous class. I can show you where. I'll not go into details again. But if you're not clear, maybe see like that relevant part in the recording. Let me show you the solution. Where it Okay, if I can't find it, I'll just prove it because I don't have that much time. I think it was after the verses.
I think we can use CRT somehow to prove that it exists.
Yes, you can. Okay, maybe I have not taught you that thing.
Or
That's
you
sort of
can
embarrassing.
you can take an integral multiple of the inverse of b. X
Yeah, you can do
equals
that. I was pretty sure I did teach you that. That's just sad. Okay. Anyways,
I have an
so
idea, but it's long.
maybe later. That I have to like do one more problem in the class.
Okay.
Okay, I'll just quickly finish this thing. So there's just one minus a, right? And one minus a, let's say it's some cube. I don't care. It's something. And now x should be just congruent to q times b inverse mod product pi. And when does an inverse exist? Like, when does b inverse exist?
When B is co-prime to all, like the
Yes,
one we are taking that.
when GCD of this thing is 1. I leave this as an exercise to prove that this should be 1. Exercise. It's not hard. Just think about what we did in the problem. Okay, the main takeaway that I wanted to give from this problem is, see, the first part was easy. You just did it. But this new part, like you'll see in a lot of typical NT, like this is sort of standard type of NT questions in which you have to like take, let's say you have to construct a long set or an infinite set, right? You take a finite set first. You try to increase the size of that set somehow. Okay. Uh, and now, like, to increase the size of the set, you just have to add at least one more element in the set, right? This is one common idea. The second common idea is to consider this set, P of S. Where did I consider? Yes, the second common idea is to consider this set. This will be used like a lot more often than you would expect. Okay, maybe not in like, let's say, INMO level question, but at least some China TSTs you will see this idea being used. Very bad reference, but whatever. Like, maybe not this particular set, but the set of primes dividing a particular set is a very important set in general. Okay, this is used a lot often, and then to work with that set. These are the two main takeaways. And then this was the standard NT part. If you just spot this, like, I don't think this you should have trouble after finite practice and finite amount of time while trying the problem. Okay. I'll just do a quick poll if the problem is clear to everyone. That took longer than expected. Maybe if people are interested, I might extend it a while. If the another problem takes time, that's not an issue. Wow, poll is taking time to load. Oh no, there. Is the problem clear? Yes. No. Okay. Okay. Oh, it is slow because I'm on phone's internet today, I realized. Yes, I launched the poll. Please answer the poll. This was not a China TST, but I was just telling that this idea I have seen in some China TSTs.
Yeah, this is the problem I sent in that also.
Three people said no. If you have any questions, please ask. In the meanwhile, I'll give another problem. I'll answer your question like right now. It's better if you ask, like that's the point. Oh yeah, just a second. If you have question, I'll just quickly explain this problem and then you can ask. So you have this sequence where AI is 2 to the power 2 to the power 2 to the power I times. You have to prove that for any given n, this sequence modulo n is constant. Okay, try it for 4-5 minutes, and yes, whoever has doubts can ask now.
Can you repeat the question?
This is the question. Like, you have this sequence, you just have to prove it's constant modulo n. Eventually constant. Okay, let me explain what does eventually constant mean. So if I give you this sequence, let's say 1, 3, 5, 7, 9, 11, 11, 11, 11, so on. And this is 11 anymore. So this is eventually constant. Like after a point, everything is just constant. So that is what eventually constant means. Like it's possible that the sequence, let's say your n is 2. It's possible that the above sequences, let's say 1, 2, 2, 2, then maybe it's 1 again, 1, 1, 2, 2, 1, 1. But after some point, it will be constant. Like it will be like either all ones or all twos. It will be constant. That is what eventually constant means. So you have to prove that this sequence is eventually constant.
Yeah, this problem is a very bizarre
Aditya, if you
idea.
have done. Yeah. But we have discussed that idea slightly before.
Maybe we can show
I'll
that
give another problem.
that eventually there is a 2 to the power a such that 2 to the power a is 1 mod n for any n.
That might not be true. Let me think of a counter example. Okay. Counter example. N equals to 2.
Bhaiya, we can take two cases. If n is a multiple of 2, then we can just divide it however many power it is of 2, and then it would eventually become an odd number. And when it's an odd number, then we can show that it would eventually be 1 mod 2. And if n is 2 power something, then it's always 0. The like 2 mod.
What
Something.
about n equals to 6? It does not fit in either of your categories.
Bhaiya, I'm saying that if n is like 6 or 10 maybe, then we can divide it by 2. Like it would 2 power 2 power 2 power 2. It's stacking, right? So we can divide that power, and that then we can solve it, because then it would become an odd.
Okay, right. I see what you're saying. But I don't think it's always one mod odd numbers. I just can't think of a counter example, right? Oh, it actually might be. Okay, what exactly do you do for n equals to 6?
Basically, we show that n equals to 6 is 2 into 3. So for once we take out the 3 as separately, and we show that like it would 2 power n would eventually be a multiple of 2 anyways. So we need to show basically that it would eventually become 1 mod 3.
Right. So you are basically saying that you're basically trying to use CRT somehow. Like you are saying that this sequence, let's say the sequence is AI. For large enough AI is congruent to 0 mod 2 and AI is congruent to 1 mod 3. So like by CRT, this will give you AI equals to 1 mod 6. Not 1 mod 6, 2 mod 6. No, bro, this is 4 mod 6, right?
Let me see again if there's some problem.
Yeah, it will be 4 mod 6. But why should it be 1? Can you prove that? I think you should be able to.
Two would be co-prime to any odd number. So like when eventually has to come.
Yeah, no. It eventually has to come to 1. But what's the guarantee that it stays at 1 with the whole, like let's say 2 to the power 2 to the power 2. Let's say this is like 2 to the power 4, right?
Yes.
And if I take modulo 3, it comes to 1. Like it does come at position 2. But what is the guarantee that it comes at position 16 as well? Like in this case, it's trivial.
Basically, 1 power 2 or 1 power anything is congruent to 1.
What?
Like let's say 2 power n is congruent to 1. So 2 power n whole power m would be congruent to 1 power m. So 1 power m is always 1.
That's
some
the correct
moment.
idea.
Yeah, but are you sure that 2 to the n whole to the m is like that? Like, can you write it like, because when I tried this, I also thought like that. But when you're taking something to the power, it's the powers are multiplying. It's not actually going to the entire power, if you see it.
Yeah, that is. No. Wait.
Like,
Right.
think about it. Like,
That is
think
sort
about
of
it.
true though. Like, yeah. I get what you are saying. No,
When you're
I mean, it's still fine. Like, let's say you have 2 to the power n, and like, even if you take, because you compute that first. Like, if 2 to the power n is 1 mod n, let's say, m, then you sort of have to prove is 2 to the power m square, also 1 mod n.
Yeah,
It would be
going from
2
2 to
power
the
m
n.
whole power 2. It's
Yeah, this is m
basically like,
square.
yes. So see, 2 power m would be 1 mod n. So it's basically power to the power. Acha, okay, got it. What's my problem?
It's
You
very
you
difficult
compute
to
it.
go from 2 to the
I
m
mean,
to 2 to the
I
n.
think you can still compute it. No, I mean, like, it's fine though. Like, okay, you can write m as m plus m, so on till plus
Yes.
m times, which is
I
just
think we
2 to
can
the power
have
m.
2 to the power n whole to the power m.
Is
Sorry,
it 2 power m square or 2
what?
power 2 power m?
2 to the power m whole power m.
You are saying this thing?
Yeah.
What about this?
That's 2 times square.
Oh, true. Yeah, I mean, you can just do that. Yeah, I mean, this is fine. But okay, like, but even for this to be true, you have to show that this m here is a power tower. Like, they should also be of this form only, right?
Yeah, but then how can we show the next one will be 1 mod n?
And that is fine. That is fine. Like, the main idea of this problem is ai plus 1 is just equals to 2 to the power ai. Oh,
Yeah,
you're right.
that will be 2 power m. 2 power 2 power m. I think.
Yeah. This will be 2 more. No. This is just annoying.
You can't prove that that number will always be 1.
Yeah, it won't be. It won't be 1 mod n plus. Okay, I see the counter proof as well for someone who doesn't. Okay, that will just spoil away the whole problem. But it does not work. I see that as well.
Yeah, also,
I can tell you. Go on.
yeah, so I had one idea when I was trying to solve this problem. I can consider first thing is
1 second. Have you solved this problem before, or just
I,
tried?
I just know the solution, but I still didn't understand it. So yeah, I will just go with my
Okay.
idea.
Maybe then don't speak. You'll understand the solution right now, but that might give away some important ideas. I hope that's okay. You can send me in private chat. If it's not the spoiler, I'll tell it. Is that okay?
It's not actually a spoiler, but okay.
Okay, then go on. Fine, you can say it.
Yeah, so what I did was, first of all, I thought that n can be many things. For example, n can be a power of 2. And if n is a power of 2, it will eventually become 0 mod thing. 0. It will
Right.
eventually become 0. Next is I can say that n is even and n is odd. There are two cases where n is even and n is odd. So
Yes.
what I thought was using CRT, if we can show that there when in even n there will be a solution. It means, for example, if there is a solution in n, means or solution in odd n, then using CRT I can tell that there will be a solution in even n, because 2 to the the 2 to the power means how can you write a even?
Yeah, I got it. Yeah, I got it.
So
Continue.
you need to show that there is there will only exist a solution for odd n. That is just the problem. So now showing for odd n, what I tried doing was there only I just got stuck. That what I tried for odd n was I can say that one term 2 to the n, and I just tried playing with primes, by the way. So if I take any mod p, by the way, so if I say
Yeah,
mod
you just have
p,
to prove it for prime. Odd prime is you're proving for n.
yeah, odd, or I can just prove it for odd primes and prime powers, and I'm done. But the thing is, for primes, I'm not sure what to do, because FLT does not work that well, because
Right.
going from 2 to the m is very difficult, as we were
Yes.
discussing. So FLT does not work, and if I say the other thing, it will be a spoiler. So I'm not saying.
Yeah, I mean it's not very direct when you have to deal with primes in this case, because like you don't generally know how to deal with this power tower. I mean, I don't know if that's the official term, but I'll just call it.
Yeah, that's what you can't deal with power turn as
Okay.
easily.
Yeah. Okay. So the idea I said is AI plus 1 equals to 2 to the power AI, right? So if let's say an plus 1, okay, n is a bad variable. Balaji, please don't annotate. ak plus 1, ak plus 2, so on. This is constant modulo n. If this is constant, this thing is same as saying 2 to the power ak minus 1, 2 to the power ak, 2 to the power ak plus 1, so on, is constant modulo n. Right? Is this
Yes.
true?
Yes.
Right. In the last class, we discussed this idea. I don't remember how my last class notes looked like. It's just sad. It was somewhere. Come on. Don't do this. Yes, yes. Like, if we are dealing a to the power b mod n, then the basis, then this thing is equivalent to a to the power b mod phi n times mod n. We discussed this in last class, right? So we
Yes.
sort of use this thing here. Like now, when I'm writing this mod n, like let's say 2 to the power a t mod n, this thing is 2 to the power a t mod of phi of n mod n. So now, if this thing is constant, like if this thing is eventually constant, then so this thing should also be eventually constant, which means that ak, if ak mod phi n, ak plus 1 mod phi n is constant, then my this sequence will be constant. Is this clear? Then why should this be true?
No, it's not clear to me, by the way.
Okay. See. Let's rephrase in a different way. Are you well versed with the fact that, I mean, I discussed in the last class, so you actually should be, that this thing, forget about everything before. Do you agree that this is true? Is this fine?
Yeah.
Yeah, I guess, yeah.
I mean, you were in the last class, right? I discussed it there. Like this idea.
For n odd.
Like,
okay, good.
Like, I can add a to the power b as a to the power phi n times a to the power b minus phi n. And I can just keep doing this. So I can just write b as modulo phi of n.
Got it, yeah, got it.
Right? Now, so, okay, if at mod phi n is same as at plus 1 mod phi n, this implies 2 to the power 80 mod phi n is congruent to, in fact, it's just equal to 2 to the power 80 plus 1 mod phi n, right? Okay, for clarity, we can tweak the definition a bit and just say that this thing is the number between 0 to phi of n. So now it's just like one unique solution to this. So is this clear that why this should be true?
Yeah.
Right? And if I take mod in both sides, this is true, right? Like since this is just equal, this will be also true modulo n, right? For any n. Is this clear?
Yes.
Yeah.
Cool. Now, just use this thing here. Like this thing is congruent to this thing mod n. So this is just 2 to the power 80 mod n. And this thing is 2 to the power 80 plus 1 mod n. Right? So this is fine. So like if these two things are, if this is true, then I get that these two things are congruent mod n. Right?
Yeah, works.
Right? So basically, my problem was that I have to prove 2 to the power ak, 2 to the power is congruent to 2 to the power ak plus 1, is congruent to 2 to the power ak plus 2, so on, till mod n, right? But now I have just said that this is equivalent to proving ak congruent to ak plus 1, congruent to ak plus 2, so on, mod phi of n, right? Is this clear now? Aryan, since you were asking, is it fine? Yeah, so Anton, go on.
Yeah, it's quite.
Yeah, it's fine.
Yes, cool. Now can you finish?
Yes, I think we can we just repeat this process and like the phi n, it just this becomes phi of n and it becomes smaller each time.
Yes, I mean you don't even need to do that. You just induct, like strong induct. Assume that this is true for 1, 2, so until n minus 1. Now you have to prove it for n. Phi of n will be somewhere in this thing, right? Like phi of n is obviously less than n. It's the number of integers co-prime to n. That's it. Which will be obviously less than n.
Yes.
So you're
Okay.
done by induction.
Okay.
Okay, the main idea in this problem was how can I express this thing nicely? That is first thing. Like this seems a nice sequence this way, but number theoretically does not tell me anything because as Aryan said earlier, we don't know how to deal with this power tower modulo n in general, right? So first you have to find a nice way to like represent this. I mean, it can be this way or some other way, but we found this way is a nice way that ai plus 1 equals to 2 to the power ai. Then we see if this is like constant modulo n, what is the statement equal to? Like now we see that there are powers involved, right? So if this is constant modulo n, the powers should be constant something. But the nice thing about powers and bases are they work different in modern. So like this thing like base works modern, but the power works mod phi of n in some way. Like I mean, if you see the previous slide, that should be more clear that statement. So we just work in that now. So now instead of dealing with bases, we just deal with powers. And then we just basically see the induction. Okay. I'll just create another poll if this is clear. Okay, my knees are tired because I'm sitting on the floor for the past hour. Is that yes. Okay, please answer the poll. The source of this problem is somewhere. Let me see. USMO 1991 P3. No, it's not punishment, bro. I don't have a table here to teach. So I sat on the floor and like I'm leaning on my bed. Oh, I did not know of that question before. Aditya. Can you send me the AOPS link to that question? I might add it in PSET if it's selected. Okay, let's see the poll. Okay, one person did not like the explanation, which is sad. But okay, most people answered it. If you have any doubt, whoever marked no, please ask. Okay, that was it for this. Okay, I just want to know this one last question. Do you now feel better about number theory problem solving, like using modular NT? Like, do you feel that you learned some ideas? Feel free to give feedbacks. I don't bite. I'll stop recording by the way.